In this podcast episode, Andrew Huberman delves deep into the neuroscience of fear and trauma. Far from being mere abstract experiences, fear and trauma are rooted in distinct biological circuits and chemical processes that can be engaged, reshaped, and ultimately transformed with the right therapeutic tools and strategies. How exactly does fear embed itself into our nervous system? And importantly, how can modern science help us erase or at least alleviate these burdens? To truly grasp fear, Huberman insists it is first critical to define what fear is and what it is not. Fear is an emotion that combines bodily responses such as heart rate changes and sweating with thought processes including memories and narratives. Unlike stress, which is a physiological response, or anxiety, which often precedes future events, fear requires a tight nexus of stress and anxiety elements but stands apart from each. Trauma, then, is not just fear. It is fear that becomes maladaptive, a pathological embedding of fear within the nervous system that repeatedly triggers inappropriately and disruptively. Central to this understanding is the autonomic nervous system, split into the sympathetic branch, which increases alertness, and the parasympathetic branch, which calms the body. Huberman highlights the HPA axis, the hypothalamic pituitary adrenal axis, as a critical three-part neuroendocrine system controlling the release of stress hormones like adrenaline and cortisol. This axis doesn't simply turn fear on and off like a switch. Rather, it sustains a fear response over time with chemicals that can affect gene expression and brain circuitry for days or longer. This long tail of fear is what often makes trauma so persistent and difficult to erase. The amygdala is then introduced as the brain's final common pathway for fear, a threat reflex center shaped like an almond but functionally complex, integrating sensory inputs from all modalities and memories from the hippocampus. It sends outputs not only to the hypothalamus to activate hormonal alertness, but also to dopamine systems traditionally associated with reward and motivation. Why would a threat center activate reward circuits? Because this connection offers a pathway to rewire fear into positive experiences, a key insight into therapies that aim to replace fearful memories rather than simply erase them. The prefrontal cortex serves as the brain's meaning maker, attaching narratives and purpose to the pure reflex of fear. This top-down processing grants us control over fear responses, allowing us to persist or retreat based on the stories we tell ourselves. But knowing the biology is only the beginning. How do we ultimately transform fear? Fear and trauma are, at their core, forms of learned association established through classical conditioning, a process discovered by Pavlov. Like the dog that salivated to a bell after it was repeatedly paired with food, humans learn fears often through singular, vivid events or repeated exposures. Sometimes one intense, fearful incident can taint entire places or experiences, demonstrating the brain's powerful ability to generalize fear from isolated moments. Extinguishing fear, however, is not about wiping memories clean. Huberman emphasizes that fears must be replaced with new, positive associations. What does this mean practically? It means behavioral therapies that involve repeated, detailed retelling of the traumatic event in a safe environment, such as prolonged exposure therapy, cognitive processing therapy, or cognitive behavioral therapy. Though recounting trauma initially spikes anxiety, over multiple sessions the physiological fear response diminishes, weakening the original association. Simultaneously, crafting a new narrative, one imbued with safety, control, and hope, is essential, engaging the dopamine reward pathways to wire in fresh positive memories over the old fearful ones. Can storytelling and narrative really remodel your brain's fear machinery? According to Huberman, absolutely. The prefrontal cortex's ability to generate meaning serves as a powerful lever in overcoming fear and trauma. Traditional talk therapies are sometimes supplemented with innovative drug-assisted approaches that modulate the brain's chemistry to facilitate fear extinction and relearning. Ketamine-assisted psychotherapy offers a form of dissociation, allowing trauma survivors to recount painful memories from a detached viewpoint. This alteration in emotional experience helps reduce the intensity of the original trauma, while naturally fostering new, healthier narratives during sessions. Although ketamine shows promise, especially when trauma is complicated by depression, it is not a universal cure. MDMA-assisted psychotherapy stands apart by simultaneously boosting levels of both dopamine and serotonin, neuromodulators that underlie motivation and contentment. This unique neurochemical cocktail induces profound feelings of connection, openness, and trust, creating fertile ground for rapid relearning and new positive associations with previously traumatic memories. How does a compound often associated with recreational use become a tool in trauma recovery? Because it creates an unparalleled empathic and emotional state that can break down fear's grip swiftly and safely in a therapeutic context. Not everyone has access to specialized psychotherapy or assisted treatments, so Huberman also outlines accessible self-directed methods grounded in neuroscience. One such technique is cyclic hyperventilation, a brief, deliberate, daily stressor that elevates autonomic arousal through controlled breathing patterns. By voluntarily activating the body's stress systems in a measured way, this approach may help recalibrate overactive fear circuits, particularly when paired with trauma recounting in a safe setting. Huberman cautions that this practice is not for everyone, especially individuals with anxiety or panic disorders, and ideally should be done with professional guidance. Yet the principle of controlled re-exposure to stress aligns with the broader theme, confronting fear strategically to retrain the nervous system. Beyond behavioral techniques, lifestyle factors like nutrition, sleep, and social connection form the essential foundation for resolving fear and trauma. Surprisingly, natural supplements like saffron and inositol have demonstrated notable anxiety-reducing effects in clinical studies, potentially complementing other therapeutic efforts. But timing matters. Suppressing anxiety during sessions aimed at amplifying traumatic memories may blunt progress, so such supplements are better used outside of active fear extinction work. By illuminating the intricate biological underpinnings of fear and trauma, from the molecular to the cognitive, and by mapping out a logical framework for how these circuits can be engaged and reshaped, Andrew Huberman offers not just scientific insights, but practical hope. The key takeaway is clear. Fear is neither a fixed destiny nor a problem to be erased outright, but a dynamic system that can be recalibrated through repeated exposure, narrative transformation, and biochemical facilitation. The question now becomes, how will you engage with your fears? Will you hold them at arm's length, or will you lean into the discomfort to rewrite their story? Understanding fear as a complex interplay of brain circuits and cognitive narratives reminds us that healing requires both science and self-awareness. With the modern tools evolving in neuroscience, trauma need not be an unchangeable shadow. Instead, it can be a chapter rewritten with purpose, support, and resilience. What new narrative will you create for your own fearful stories?